Okay, we've got our final reaction with alkenes. In this case, we're going to look at oxidative cleavage. So the final product of oxidative cleavage doesn't actually look like an addition reaction, but the mechanism involves addition along the, or to the carbon-carbon double bond. One example of oxidative cleavage is ozonolysis, and what happens in oxidative cleavage, in this case the result of reaction with ozone, is we break the carbon-carbon double bond, and we're left with two carbonyl groups where there was the bond to the carbon here, now it's got a double bond to an oxygen, and the same thing on this side. So you may remember from Chem 1211 1212 that ozone is O3 and exists as a resonance hybrid of two contributors, where we have partial negative charges on the outside oxygens and a partial positive charge on the middle oxygen. All right, so this slide shows the mechanism for oxidative cleavage, and you're not going to be responsible for the mechanism, but I just wanted to show it to you. And this mechanism is kind of crazy. There's a lot going on. In the first step, we have a nucleophilic attack from this end of the ozone, along with a nucleophilic attack from the pi bond to this oxygen, and we form this ring structure. Then we have sort of the loss of a leaving group here and here. And we've got just sort of a resonance here, producing these two carbonyl groups. They then rearrange. We get two more nucleophilic attacks to produce this ozonide. And then if we hit it with a mild reducing agent, we get our final products. And common reducing agents are either dimethyl sulfide, which we'll typically abbreviate as DMS, or using metallic zinc with water. Okay, so that was a crazy mechanism. What's the take-home message for oxidative cleavage? If you see our alkene being reacted with ozone, and then some other mild reducing agent like DMS or zinc, right, the key, I think basically when you see ozone, right, we're going to split our alkene, and we're going to break it at the carbon-carbon double bond, right, and we're going to replace, on each one, the carbon's going to replace with the double bond O. So let's take a look at an example. All right, so we're hitting this with ozone, right? This tells me this is oxidative cleavage. I've got my mild reducing agent. And so we're going to, in this case, we have two alkenes, and so we're going to break them both. We're going to break it here, and we're going to break it here. And so a trick from drawing the products that I like from the book is if you first elongate your carbon-carbon double bonds. So let's redraw this, right? I'll elongate my carbon-carbon double bonds. And then we can just go in and erase the middle of the bonds, right? And then where we deleted them, we get oxygens. And so this is effectively our product. Now I might redraw it. My handwriting's kind of crap there. So right, our two products are going to be this guy. And then we could leave this thing in sort of the ring formation, and that would be fine, but I'm going to redraw it so it looks a little bit neater. And so I have, right, 1, 2, 3, 4, 5, 6 carbon atoms. So one, two, three, four, five, 6 carbon atoms, and then I've got a double bond O on the end. I then have one carbon and then the other carbonyl group. And then I have 2 carbon atoms and the other carbonyl group is on the end. So here's my 2 carbon atoms. The carbonyl group will be on the end. And there are our 2 products. Now in this case, we have these aldehydes. You're absolutely okay with leaving it like this, but very often when you see people draw aldehydes, sometimes they go ahead and show the hydrogen here, even though you don't have to.